Welcome back to our journey with TypeScript. In our TypeScript series, we learned to write type-safe, predictable code. We use decorators, generics, interfaces, and all the powerful features that make TypeScript incredible. But here's the reality. TypeScript doesn't run in browsers or Node.js directly. TypeScript is a language that compiles to JavaScript. Before we write a single line of production code, we need to set up the environment properly. Think of it like a film studio. Before the filming begins, you need a sound stage, that is your workspace. You need lighting rigs, that is your build tools. You need a camera equipment, that is your TypeScript compiler. And you need production guidelines, that is your tsconfig. Without proper setup, your code becomes chaotic and unmaintainable. This script teaches you how to set up TypeScript like professionals do. The real world problem. Why setup matters? Imagine you are hired as a developer at a tech startup. Your first task is to contribute to an existing TypeScript project. You clone the repository and try to run the code. So you will come across, whenever you clone the repository, you will come across a file named as package.json. So what is this package.json? So in your package.json, you will see some details like this. So it will have a name, it will have version, it will have description, then it will have your main, and it will have some scripts also. It can also have some keywords. It will have the author, it will have the license, dependencies, and dev dependencies. So what are all these? So let's get into detail. So over here, this name is the name of the project. So in this case, I've named it as my TypeScript project. So this is the name of my TypeScript project over here, the version that I specify. So this was my first version. So I've specified it as 1.0.0. The description is, it gives you a brief idea what the project is about. So I've just given a brief description over here. This main is where your code will run. So in this case, it will, my index.js is in a folder named as dist, and I have a index.js file. So this index.js file has all my main code, which will run when I do the command node index.js. Then we'll go to the scripts. So what are these scripts? As you can see in the scripts, I have this dev and I have written some commands. So these commands actually we use in our node code to run few commands actually. So whenever I do, let's say npm run dev, what it will do is it will check in the scripts for this dev command, and accordingly it will run this. So in this case, it will do the ts node of src and index.ts. If I do npm run build, it will TypeScript compile because I've specified tsc over here. If I do the npm run start, it will do this. It will go to the dist index.js and it will run that particular file. If I do the ESLint over here, that is npm run lint, what it will do is it will do the ESLint and of this particular path, which is src and any folder inside src and any file .ts under src folder. Then we'll go to keywords. So keywords you can use to identify what your project is written in. So let's say this particular project was using Node, and also I've used TypeScript in my project. So those are the keywords that I've specified. In place of author, you can specify any name over here. Let's say I had only developed my this application, then my name would go over here. Let's say I was working for some organization and they have developed particular app, then their name could go over here. This license is the license of the app basically. This dependencies is actually all the dependencies that we use in our project. So let's say I'm using some external npm libraries, then those will come over here along with their specific version. Then this dev dependencies is also any dependencies that the developer requires. So for example, I'm using the Babel compiler. So that dev dependency will come over here in along with the specific version of that particular compiler. So this was a brief overview of package.json. Do you have any questions on this?
These all are setting things as a convenience, right? Or is it mandatory to set up this before, starting your project each and every time?
See, now if we have like let's say a React app or a Node app, then your package.json is kind of like a it's mandatory, I would say. Because see, in our applications, in large scale applications, we don't just write each and every code. We sometimes import external libraries. We use third party libraries also. So that time having a package.json helps us a lot, because in the dependencies we can specify all the external libraries, all the libraries that we have used in our particular code. Also, each time running, let's say I've each time doing ts node a particular this file, then doing the node, all that becomes cumbersome. Instead, what I can do is I can just specify, let's say this dev command, and in this dev, I can specify all the commands I want to run. So this becomes much convenient actually.
Uh, what role do scripts play in the workflow?
See, scripts are basically to help developers over here. See, if I didn't have, let's say, this dev script, if I didn't have this dev script, each time to run my particular code, I would have to run this command, ts node src index.ts. And each time I would have to do that. But instead of doing this, what I can do is I can just call this dev by the command npm run dev, and it will automatically handle all this. So let's say now I don't have to even keep track of this if I'm in the src folder and this particular file index.ts also. So that it becomes convenient for the developer also. Currently, like I've shown you just one command, but there can be many commands also in this dev. So each time running multiple commands, it will kind of increase the workload of developers. So instead, using these scripts can help us a lot. Let's look at the next script now. So next, if it's a TypeScript project, you must have come across something known as tsconfig.json. So what is tsconfig.json? Tsconfig is all your TypeScript configurations that are there in this file. So let's see. So I have a object named as compiler options, where I have my out directory. So here I've specified dot slash dist. So all my Node.js code, all my TypeScript code, which is there, like let's say this index.ts. If I do the tsc for that particular file, I want it to create a .js file. So I want that compiled code to be in this folder, dot slash dist. So this is my out directory. So it is basically where to put the compiled files. My root directory. So this is the folder where I want to find the source file. So basically where I will have all my .ts files. So that I've specified as dot slash src. So which is this. Then my target is my which JavaScript version I want to use in my particular code. Currently, I've used the latest version, that is ES 2020. My module is what kind of modules I want in my particular application. CommonJS is the mostly used for Node.js applications. Strict will enable actually type checking for this thing, like for your types basically. So over here, if we set it to true, then it is kind of enabled over here. But if we set it to false, then we can disable this. No implicity any, no implicit any. This is also set to true. So this is like we need to return the explicit return types over here. We can't specify any implicit ones. Then no implicit this. So this is to it shows that a variable is used before declaration. So if there is any variable which is used before declaring it, then it would give an error over here. So we have set this to true as well. The source map we have set to true over here. So this will generate the source maps. So this is useful for debugging our applications basically. Then we have the skip lib check. So this lib check is TypeScript's inbuilt method to check for errors actually. So what we are doing here is we are skipping the lib check over here, the library check. We have set this to true as well. If we set this to false, then it will by default run the lib check over here. The ES module interrupt is this thing. It's to resolve the common JS and ES6 modules. So how we want to do that? Uh, Allow synthetic default imports We have set this to true. So this allows all our common JS imports. So any Node.js libraries that we have specified in our code, it allows us to import those. Now, this include is an array, and we want to include all the files which are in this src path. So in my src, I can have many subfolders, and inside that, I can have more files. So I want to include all those files which are there in src path. And these are the files that I want to exclude from these rules. So that are my node underscore modules, this folder, and my dist folder. So this is a basic overview of tsconfig.json.
Nandan, how is this configuration set up? Compiling the sources from the src file to the output directory that you have provided.
See, this tsconfig.json is actually we are telling TypeScript to follow these particular rules basically. So now over here we are telling it where our source code is. So over here we are saying that all our source code is in this src folder. Now once it compiles all our code, it has to store it somewhere. So we are telling it to store in this output directory, which is /dist. Then over here, we are telling TypeScript that use the latest version of JavaScript, that is ES 2020. Also over here, we are telling which module we are using. So that is CommonJS. So this is mostly used for Node.js applications. So this we are telling. And all these other rules like strict true, no implicit any. So these are kind of all the rules that we are telling TypeScript, the compiler to follow while compiling our TypeScript code.
This is more like a checklist or a blueprint, right?
Correct, correct. More like a checklist. Correct. Let's look at the next file. So our next file in the application is eslint.rc.json. So this file. So even if the code is type safe, it can still be messy. So in this file, what we do is we specify the parser. In this case, we have specified the TypeScript eslint parser. Then we pass the parser options over here. So we specify the ES version. So that is ECMA version over here, which is 2020, the latest version. We specify the source type, which is a module over here. We specify the project. So that is ./tsconfig.json, the previous file that we had seen. There is a array known as extends. So we extend all these rules over here so that ESLint is recommended and plugin type is of type this TypeScript ESLint and /recommended. Then we have certain rules over here. So let's say anywhere in our application, we have some console.logs. So actually in our production code, we should not have any console.logs because that is not a good practice. So we can actually ensure that we have no consoles in our production app by using this no console one. So if there are any console logs in our application, it will warn us if we use this particular rule over here. Also, uh, let's say there are some function, we have not specified the function return types anywhere, then it will warn us over here. So it will require explicit return types for each function. Let's say we have some unused variables. We have just defined some variables in our code, but we have not used them. So in that case, this particular statement will give us an error saying this particular variable is unused. Also, we have for semicolons, we always show the error over here. So by this format, error always. Let's say I have also missed to close any quotes. So in my console, there is some string and I have not closed the quotes of that. So even over here, it will show me the double quotes and it will show me the error over here. Here I specify my environment. So this is my environment is Node and my ES version is ES 2020. So this is the eslint rc.json file. So these rules enforce that there are no console logs in production code. Functions must have explicit return types. Unused variables are errors. Code must use semicolons. Code must use double quotes. So we learned about setting up the environment for building real-world scalable projects. We will meet in the next session. Until then, keep coding.